Hi, I'm Denny Lee, a Principal Program Manager for the Azure Cosmos DB team. In this video, I'm going to show you real-time analytics with Azure Cosmos DB and Apache Spark. Before we dive into analytics, let's start with the Cosmos DB change feed feature. As a fire hose of data is inserted into Cosmos DB, the change feed allows downstream streaming and batch compute to process the data. This allows your systems to keep state of your data while processing it in real time. Real-time analytics starts with a Lambda architecture that allows you to make sense of data both in batch and in real time by having separate batch and speed layers to push your data into. The master data is comprised of a master data set and the ability to pre-compute the batch views within the serving layer. Meanwhile, the speed layer provides the real-time answers to compensate for the serving layer latency. All queries can be answered by merging the real-time and batch views. By using Cosmos DB change feed, you can push data only into the batch layer, simplifying operations. The Cosmos DB change feed streams the data in real time for HD Insight using Apache Spark to process. A little more on this later. We can use the same Spark infrastructure to perform our computations from Cosmos DB directly for batch aggregate queries. For example, the number of tweets with machine learning in the past few days or months. The results are pushed into another Cosmos DB collection, so many clients or users can query the results concurrently. Meanwhile, Spark Streaming is running another job constantly processing the stream of change feed data. The speed layer calculates its algorithms or aggregations at a lower latency. For example, while the serving layer provides the number of tweets with machine learning in the past few days, the speed layer provides the number of tweets for machine learning in the past few seconds. So let's simplify the Lambda architecture by using only Cosmos DB and HD Insight Spark. As you can see from this notebook, we're going to push all of our data, in this case Twitter data, into Cosmos DB for processing. The batch layer is going to go ahead and has the master data set, which is an immutable append-only set of raw data, which we pre-compute the batch views, after which we're going to serve the data to our users. So let's start with this particular demo. The next set of code that you see here is for us to configure Spark to talk to Cosmos DB. This first one allows us to connect to the Spark connectors, and this second one here allows us to go ahead and indicate we're going to connect to the Rainier Cosmos DB database. Once we get through here, now we can run our tweets. So right now we have a batch of tweets. Let's go and figure out how many we have. So we do a select count. In this case, there are about 13,000 tweets that are inside our collection. Now this is the batch view, the original view of immutable data. So let's go ahead and take a look at the first 20 tweets. These involve tweets from AI, big data, machine learning, things of that nature. And so the tweets are right here for you to look at. And then finally, let's go ahead and scroll down and run a quick top 10 hashtags for the tweets that we recorded. So when we run this, you notice that the system will pump out, there are a lot of AI tweets, then big data, and so forth and so forth. In fact, here's a great way for us to visualize the data that we've placed into our system. Because we've processed this data, now it's sitting comfortably within our users, querying by Spark, against our batch view of collection data. But how about if I want to read just these results of data? Well, what's great is I can go back to the data here. And in this case, I'm actually querying a collection which contains the pre-recorded or pre-aggregated data similar to the view that you had seen before. So if I run it here, it's going to execute, and you'll notice the same set of information which I've pre-calculated. And so now multiple users that want to query this data can go ahead and ping the system now. So now we've talked the batch and serving layer. Let's go ahead and focus a little bit on the speed layer. So let's go back to a terminal window, which I'm going to run this particular command. This command actually is running tweets from Twitter and pushing it into the collection. So right now it's currently running and putting new tweets in. So I'm going to go ahead and look at my Spark window. From here, I'm going to go ahead and run a quick, fast query. So this code looks very similar to the code that you just saw in the previous notebook, except what's happening now is that I'm looking at things from a structured streaming or real-time process as opposed to from a batch process. So instead of actually just looking at Rainier specifically for all 13,000 tweets that already are stored, what I'm doing is I'm looking at the tweets that are being recorded as we speak. And so as tweets are being pushed into the system, the batch is showing up. And so for the first batch, it'll go ahead and calculate how many tweets by what particular tag as it's coming in. So right now the calculation's occurring as we speak. Perfect. So 466 tweets have come in so far. This is because the data is going to Cosmos DB, and we're subsequently running Spark streaming against the change feed. And as time progresses, you notice as the batch count increases, you'll see the information updating, the counts updating based on the change feed of Cosmos DB. So in one fell swoop, with both Spark and Cosmos DB, we can go ahead and achieve our Lambda architecture in a much more simplified way. If you'd like to dive deeper into Cosmos DB change feed and how Spark can work together with Cosmos DB, here are some great resources. I hope you have enjoyed this video, and if you have any questions, please do not hesitate to contact me directly or email askcosmosdb@microsoft.com or tweet us using @AzureCosmosDB or using the hashtag CosmosDB. Thanks very much.